Welcome to solverfy.
So in this problem, we are provided with some model of some compounds, and we have to find out the percentage of carbon by mass in those compounds represented by the models. So first, you have to know the formula for finding out the mass percentage of a specific element which is present in a compound, and the formula for doing that is this, where the mass percentage of an element is equal to the number of that element present in the compound times the atomic weight of that specific element over the formula weight of that compound times 100%. So our first model here is this, where this black sphere is carbon and this red spheres are oxygen. So from here, our formula of the compound is CO2, and that means the formula weight of this compound will be simply the sum of the atomic weights of each atom present. So we have one carbon, that means carbon's atomic weight is it's 12.01 atomic mass unit, plus we have two oxygen, and oxygen's atomic weight is 16, and we multiply it by 2, and will give us a value of 44.0107 atomic mass unit. And then we can find the percentage of carbon in CO2 by just putting the atomic weight of carbon. Since we have only one carbon, we don't have to put the number of carbon present, 12.0, over the formula weight, which is 44.0107, and multiplied by 100%. It will give us a value of 27.29%. So this is the percentage of carbon in carbon dioxide, or the model given here. Then I move to our next problem, where our this again this black sphere is carbon, and this red sphere is oxygen, and our white spheres are hydrogen. So we have um, four hydrogen present. Three of them are bound to carbon, that means it's CH3, and then oxygen, and then the rest of the hydrogen is bound to that oxygen, that means this is an OH, and this region is CH3. So CH3OH is the formula of the compound, and if we find out the formula weight of this, we have one carbon, 12.01. So I'm not writing here the atomic mass unit every time, but while writing in the exams, you should have written the unit very carefully and write down 12.01 AMU, or for oxygen, all the atomic weight should be presented in AMU, or atomic mass unit. All right, so the atomic weight of carbon is 12.01, plus we have four hydrogen, and hydrogen's atomic weight is 1.008. We have four hydrogen multiplied by 4, and then we have one oxygen, which is 16.0, and it will give us a total value of 32.04 32.043 AMU. So this is the formula weight of this, and then the percent of carbon here will be, say we have only one carbon here. Again, we just put the atomic weight of carbon over the formula weight is 32.043 times 100%. It will give us a value of 37.48%. So this is the percentage of carbon is CH3OH, or which is the formula for the methanol. Then we move to our next problem. Here we can see that we have two carbons and three hydrogen bound to each carbon. That means the formula is CH3, or we can write it as C2H6. So the formula weight for this compound will be simply 2 carbon we have 12.01 times 2, plus we have 6 hydrogen 1.008 is the atomic weight of hydrogen, times we have 6 hydrogen, and the total will give us 30.0694 atomic mass unit. And make sure you write AMU after every atomic weight you write. That means 12.01 AMU and 1.08 AMU. And then the percent of carbon will be equal to, since we have 2 carbon this time, we put it 2 here times 12.01 AMU over this formula weight, which is 30.0694 AMU, multiplied by 100%, it will give us 79.88%. So this is the mass percentage of carbon in C2H6. And finally we have this formula where we can locate one carbon in the middle. Since the blue one is nitrogen, we have 2 nitrogen, and we have 1 sulfur, and we have 4 hydrogen, which are white ones. So the formula we can write is CH4 into S. So this is the formula of the compound, which is represented by this model, and formula weight for this will be equal to, for carbon we have 12.01, plus we have 4 hydrogen, and 4 hydrogen atomic weight is 1.008 times 4, plus nitrogen's atomic weight is 14.0067. We have 2 nitrogen, and we have 1 sulfur, which is 32.065. It will give us formula weight as 76.121 atomic mass unit. And then the percent of carbon will be, still we have only 1 carbon in this one too, so 12.01 AMU over the atomic weight, or the formula weight of the compound, which is 76.121 times 100%, it will give us 15.77%. So this is the uh, mass percentage of carbon in the compound represented here.